Let's talk graphing systems. So the first vocabulary word I have here is consistent, at least one solution. What would that look like if I was graphing something? We just talked about it. It would be a line intersecting lines, right? One solution, consistent. They say consistent because you can consistently say that there is a solution there. So what would inconsistent be? If consistent means there's solution, what would inconsistent be? There's no solution. Right? Exactly, I heard it. Say it again. Parallel lines would be inconsistent, right? Independent. I'll tell you that independent solutions and dependent solutions are both consistent. Okay? So it means there's a solution there. Independent would mean there's only one. Right? Dependent would mean, what graph did we already go over that would be dependent? Infinite, or what would that look like? One line, the same line. So you see where they're getting this vocabulary here? Consistent means there's a solution. Inconsistent means there's no solution. Independent means it's where they cross only once, right? And dependent, if they say dependent because one is depending on the other, they're the same line. Okay? So it's just fancy vocabulary for something that we already understand conceptually, right? Don't get too hung up on the vocabulary.
So intersecting lines could be consistent and independent?
Perfect. Said perfectly. Intersecting lines would be consistent and independent. Both. Has both traits. Because you saying consistent doesn't tell me that it's intersecting at one place. Because isn't a dependent solution also consistent? Right? If it's the same line, isn't it still consistent? It has at least one solution. It has infinite many solutions. Okay, so lines that intersect, what do we know about their slopes? If it's intersecting lines, what do I know about their slopes? That would be perpendicular lines. Okay, let's talk about parallel first. Perpendicular are intersecting, but not every line that intersects is perpendicular. Let's start with parallel. What do we know about slopes when they're parallel? They're the same. Same slope. So what would be if the lines were intersecting? Not the same, but not opposite, just different. They're different. We know that if there's lines are intersecting, they have different slopes. Lines that coincide or that they're the same line, what do we know about their slopes? If it has the same line, what else is going to be the same? Same slope. Okay, lines that intersect. What's the classification system? Which one of these would you say? Lines that intersect would be consistent or inconsistent? Consistent, independent, or dependent? So consistent and independent. What about a same line? What would be its classification? Same line. Consistent and dependent. Consistent and dependent. Lines that are parallel, what would that look like? That are parallel? Consistent and dependent. Lines are parallel. Oh, I'm sorry. I'm thinking the same line. Sorry. Yes. They would be inconsistent, right? Apologize. Number of solutions for lines that intersect? How many solutions for lines that intersect? At least one. Well, no. Just one, right? If they intersect, there's only one solution? Same line. How many solutions for the same line? Infinite. And how many solutions for lines that are parallel? no solution, or 0. Alright, so this is going to be the beginning part of your homework. I like the last part of your homework. It asks you to say whether it's consistent, independent, or dependent, or inconsistent. Consistent and independent, or consistent and dependent. Okay, graph each system, pencils down. Graph each system of equations and describe if it is consistent and independent, consistent and dependent, or inconsistent. This is what your homework looks like. Alright, so what do I need to do to graph these two lines? I need to put them in slope-intercept form. Alright, so I'm going to put this one in slope-intercept form. The first thing I'm going to do is negative y equals negative 2x plus 4. Everybody agree? Now, what would I do? Divide by negative 1, or what about just take the opposite of everybody? Right? If it says the opposite of y, couldn't I say, well then, the opposite of y, the opposite of negative 2x, and the opposite of 4? Right? Pretty easy? Okay, so I'm going to graph this line. Let's make it blue. Alright, where do I begin? Begin with B, negative 4. 1, 2, 3, 4, and where do I move? Up 2 over 1. Oh, my good Algebra 2 students know how to graph their lines. Okay, there's one. Alright, let's do the second one. X minus y equals 2. How would I change that one? Negative y equals negative x plus 2. Good guys. And then opposite? Y equals x minus 2. Make that one green. Yeah? Of course. Yes. This is smaller. Green sounds good. You like red? Well, green's my favorite color, so I think that's why I go green. Okay, so where do I go? Where do I begin? Negative 2. Where do I move? Up 1 over 1. Up 1 over 1. I like to keep going up 1 over 1 until I find my solution, right? I'm going to draw a line there, and my solution is right here. Go ahead and write that. 2, 0. 1. Alright, I'm going to do this one a little bit faster. So we'll start with blue. Y equals negative x minus 2. That's already in slope-intercept form. Ooh, I forgot something. We didn't describe. Is it consistent and independent, consistent and dependent, or inconsistent? It is consistent and independent. There is one solution. Alright, so I'm going to go ahead and graph this one. So I begin at negative 2, and what's my slope? Where do I move? Up 1, to the left 1, up 1, to the left 1. I told you guys, I always go up, because you always rise up and then run to the positive or run to the negative. Okay, what about the second one? That one's not in slope-intercept form, so I'm going to have to change that. Luckily, all I have to do is just move x. Everybody agree? Okay. So I'll go ahead and graph that one. I'm going to begin at negative 4. 1, 2, 3, 4. And where am I going to move? Up 1. To the left. Everybody should be saying the same thing right now, right? There are parallel lines. You should have been able to look at it and say, well, if they have the same slope and different y-intercepts, you would know that they're parallel lines, right? The only way they could have the same slope and touch is what? How could they have the same slope and touch? If they had the same y-intercept, then what would it be? The same line, right? Okay, so since these are parallel, we have no solution. And which one of these is it? Inconsistent. Go ahead and copy that down. Okay, let's do the next scenario. So I've already got the second one in slope-intercept form, so I'm going to graph that one first. How's that sound? Fantastic. Okay, so I'm going to go begin at 4, 1, 2, 3, 4, and I'm going to move up 1 over 2. I'm hoping by now that you look at this and say, oh, that's a shift, a vertical shift up, and then the slope is 1/2. So that means that the line is going to be kind of lazy. I want you to start doing that, right? Looking and seeing what does that look like in my head rather than just graphing it. Okay, behavior of graphs, always. Over and over again, I'm going to keep preaching that. So here's this line. It's a little off. That's a little bit better. Let me manipulate the other one. So I need to keep y on this side. So I'm just going to get the 2y equals x plus 8, correct? Then what do I do? Divide everybody by 2. And I get y equals 1/2 x plus 4. It's the same. Right? I'm just going to copy it, paste it, make it blue, and put it right on top of it. We'll put them right next to each other. How's that? They are the same line. So which one of these is it? Consistent and independent, consistent and dependent, or inconsistent? Consistent and dependent. And what's my solution? Infinite solution. Question so far? That's 3-1 in your book. Now we're going to shoot over to 3-3 and do it together. Okay? What's this? I don't think we need to do this one, do we? Yes, we do? Okay, you guys try it on your own. Okay. Is this what you guys got? No? Okay. How did I... This one?
Yeah.
How did I move it over to the side?
Right.
Isn't saying something is divided by 2 the same thing as saying half of it? Right? How is it over on the other side?
Yeah.
I subtracted x over 2 on both sides.
Oh, keep that.
I think you guys see fractions and you just like all of the rules that you normally know about just like completely leave your brain.
So I thought you had triple line and one line on top.
Nope, I just moved it on the other side by taking the opposite. More questions? That's how I got to here and here, the blue and the green. If you didn't get this, what should you do? Come after school and do your homework. I'll help you with it, okay? Awesome. Okay. I guarantee you if we do a few of them together, it'll be good. Probably take about 20 minutes. All right, moving on. All right, solve each system, pencils down. Watch me do the first one. So the first thing I'm going to do is I'm going to put this into slope-intercept form. So it's going to be, this first one is going to be negative 2y is greater than negative x plus 6, correct? Then I'm going to divide those sides by -2. When I divide by negative or take the opposite, the sign switches. So when I take the opposite, the opposite, the opposite, I'm going to make this sign the opposite. So this becomes y is less than, negative over negative is a positive. There's an invisible 1 right there, right? So this is really 1/2 x minus 3, because you've got a negative down here. Okay, go ahead and do this one as well while we're at it. Color that first one. There's 1. The second one, move x again, for y is less than -x minus 4. Divide everybody by 4. Do I have to change the sign on this one? No. So y is less than, there's an invisible 1 right here, right? So that's -1/4 x, minus 1. What's this graph look like? Let's talk about the behavior rather than just graphing. How does it shift vertically? What? Real lazy, but that's not the vertical part. Right here? Right? There's a shift down 1. It's real lazy, right? That's the slope, and not only is it lazy, but it's going in the negative opposite direction. So it's going to be something like this. Correct?
How can you divide the 1x on positive or negative?
Ask me again.
Because positive 2 in this equation, how come you're not dividing it by positive 2? Oh.
It was negative. They were both negative.
Oh, okay.
And so negative over negative is positive. I think you were looking down when I did that. That's kind of why I like you guys to put the pencils down and just look up, because that's the exact reason why. Is I just want you to take it in. Because if you're doing this, looking up, looking down, looking up, looking down, you're missing stuff that I'm doing. I can go much faster. No, it's okay. I can go much faster if I've got everybody's attention and we just whip through it. You know what I mean? And then come back and do another one. All right. You're not going to miss anything. I'll give you time. It takes more time. You'd rather be taking that time to do your homework, right? It takes more time to wait for everybody to write it down as I'm talking. You'll see. All right. So the blue one. Let's do the blue one first. I'm going to be shifting down 3, and I'm going to move up 1 over 2. Is this going to be a dashed line or a solid line? You dashed. Our boundary line is going to be dashed because it's less than. It should be blue. Okay, what about the green one? This one's going to be down 1, and then the slope is -1 over 4. So I'm going to go up 1 and to the left 4. 1, 2, 3, 4. This one's also going to be a dashed line. All right, now I'm going to do my shading. I think I'll shade with this instead. Okay, let's talk about the blue line first. And if I'm standing on the blue line, am I going to stand up into the clouds or down into the clouds? Down. It's less than. So I'm going to shade down from the clouds. And the green one, am I going to, when I'm standing on the green line, am I going to shade above the clouds or below in the clouds? Below. It says less than, so also below. Now, where is it where my shading is intersecting? Where do you see green shading and blue shading? All right. Here. So copy that. All right, let's go. Solve each system of inequalities by graphing. All right, here's what I got. Okay, so let me show you on an assessment, because that's what you guys usually care about the most, right, where the points are. So one would be a point 4. You've got the correct slope-intercept form here, right? You know what your line's supposed to look like. Another would be that it's a solid line, solid blue line. Another point would be the shading above the line. There's 3 points like that. The green one, 1 point for getting y is less than 2x minus 2. 1 point for this is going to be a dotted line. Another point for shading below it. These are the hardest ones, right? When it's that steep and you're like, but isn't positive over here and negatives over here? No, you guys stand on the line and either you step up or you step down. This says you step down, right? So you shade below the line. Correct? Even if it was a line like this. When I'm standing right here, would I stand up or would I stand down? I would go down. Okay. So now, the final point, that's 6 points right there. What's the 7th point? Where is my intersection? My solution is where they are both intersecting. Their shading is intersecting over here in this corner over here. These are not fun to grade.
Yeah, that's a great one.
Because if you mess one part up, I have to figure out where you messed it up, right?
About 180%.
Okay. They don't. They intersect all in this red space right here. That's their intersection. You see why? There's no point of intersection. There's a shading intersection. Okay? That's a really good question. All right, what did you learn today? All right, what is, guys, I need you right here, please. 5, 4, 3, 2, 1. What is the difference between the solution of a system of equations and the solution of a system of inequalities? What's the difference? One of them, not one line, but one solution, and the other one is shaded solution. All right, on your assignment sheet, write, if I'm not sure that I have the correct region shaded, I will. What could you do if you don't know if you have the right region shaded? You could test a point. Absolutely. Good job. You could test a point. Test a point. If I tested a point in this one, guys, what would be a good point to test? If I did 0, 0, it would mean that both of them were wrong. Right? Is that correct? You could test 0, 0, and it would be false for both of them. You could test 1, 2, 3, 1, 2. What about if you tested 3, 3, it would be true for both of them. Correct? All right, let me get you your homework. Good job, guys.